In my other videos, I showed you how to find an article, basically access a PDF or an HTML version of an article through Northeastern's Web of Science, which is very useful. Now, how do we gather information? You do not want to search the scientific literature from within Google. It's just not going to work. It doesn't rate things the way you would like them to be rated necessarily. I can tell you a little bit about how Google works, and it is very advanced. And what it does is look for citations from or links from highly linked or cited websites. And so it's a recursive algorithm that weights things based upon how respected they are by other respected sites. So Google has its purpose, but Web of Science is more explicit and can do a lot of things that we can't do within Google just yet. So let's say we were interested in mass spectrometry. Okay, mass spectrometry. I'm going to put it in quotes here because you need to be explicit in these searches, and it's only going to search mass spectrometry, but not mass or spectrometry in the topic. And let's search and see who the most influential people are. Remember, go by time cited, and look at this: mass spectrometry sequencing of proteins from silver-stained polyacrylamide gels. Okay, that's the In-Gel Digest, one of the two. This one obviously been cited 6,000 times, and it's by Matthias Mann. Probability-based protein identification. That is the very article that led to Mascot, if I'm not mistaken, which you've been using in class to search your mass spec data and identify proteins. Electrospray ionization. That's the paper by John Fenn that led to his Nobel Prize in electrospray. And here's a great review. Okay, so those are examples of how you could search a giant field like mass spectrometry and learn. Now I'm going to return to the search, and let's say that I didn't want to look at all 400,000 articles, as you'll see as you go back there that there were 400,000 articles, and I'm only interested in cross-linking. Okay, and I'm going to learn this as fast as I can, right? I can't read through 400,000 articles, and now I'm down to 1,200 articles. Well, that's actually more useful, and if I search by time cited, now I'm looking at all of the most important, or at least the most cited, mass spectrometry cross-linking, and I can learn a lot faster. In 1,200 articles, it's tractable. I've actually learned and went through every single one of these myself at one point, and it took me about 7 or 8 days at probably 4 hours a day. What about your good and bad articles, which is something you need to do for class? Well, let's change this, and let's just change this to, for example, we're interested in proteomics. But we have to be explicit and think like a computer, whereas Google would interpret proteomics to be proteomics or proteomic. We need to do that ourselves. In other words, search both proteomics or proteomic, and look for anything that has those. Okay. Now, if we look for that and get rid of this other field, so we're just searching the most influential proteomics papers, we have it. Bioinformatic enrichment, mass spectrometry-based proteomics. We saw that review before. Exosomes, this is actually applied. MaxQuant, that's by Matthias Mann. SciLac, we've gone large-scale protein identification, more on database searching, algorithms, the big ones being, of course, Mascot and seQuest. And we keep going, and we see right here, number 14, cited 2,100 times, use of proteomic patterns to identify proteins in ovarian cancer. Now, we could go into this. We could look at the articles that actually cite it. Now, by clicking this button, that's what I'm seeing. And I could sort them by the times they've been cited. Now I can get a feeling for what other people think about this article. Okay? And if I were to look into some of these, I would notice that that this is saying that they did a bad job. A lot of these would actually say that they did a bad job on this article, more or less, and I paraphrase. Another way I could get to that same thing on that particular article is to go into PubMed. That's just search PubMed in Google, and it'll get you there. And if I typed Petricoin and Leota, because I just saw and then ovarian, and say we're interested in looking at this article. What did people think of that article? Well, we could just look through the citations like I just showed you, but in Medline, people have the option of making comments. And so if a paper really offends somebody, as this paper offended people, You could look at it here, and you could read each one of these comments and see that all of the problems that Pearl found with this article. So there's two different ways to get at whether an article is good or bad. Good is easy, right? Look for highly cited articles that people seem to generally agree with. Bad, you just have to go through a lot of articles and find something that you think is bad or that other people thought was bad. And finally, the very last thing that you can do is if you were to look at basically within Google, mass spectrometry, pretty much anything published. Hindawi publishers are not known for having great editorial standards. And so if you were to go into something like this, chances are, unless things have changed recently with Hindawi, I haven't kept up, students have had really good luck finding bad articles from that publisher. Okay, I hope this will help.